Good morning. I'd like to do a little video about the origin of life research. The thing is, recently I came across a remark of James Tour, Professor Dr. James Tour, and he said that one of the things that inhibits the formation of life is that in organic chemistry, and I am a chemist, I happen to be a chemist, and I have to agree with him that if you want to make a certain component, let's say monochloromethane, and you take methane and you take chloric gas and you combine the two in an 1-to-1 ratio, that's what's most optimal with respect to stoichiometrics, that if you have 1 mole of methane and 1 mole of chlorine, then theoretically that can react 100% to monochlor methane. And but the thing is, if you start that reaction by UV radiation or by sparking it, stuff like that, the overall, the bulk ratio of methane to chlorine may be 1-to-1, so exactly as it should be. But locally, it may very, very be different than the overall bulk ratio, which means that the yield, the expected or the practical result of the monochloromethane may not be 100% of what you expect. So there may be an amount that is not 1 mole of monochloromethane, but for example, 0.65 mole of monochloromethane. So the yield is then 65%. That's what's called yield in organic chemistry. Now, I did a little research and I wrote a paper about it, and I published it also in ResearchGate and academia.edu, where organic chemistry yields inhibits origin of life, or life inhibits life from simple chemicals. That's I think the title. I will put it down here in the below, where this yield thing is one of the factors that inhibits the formation of life out of simple chemicals. I mean, I took a book, a very well-known organic chemical book, in which practical examples have been given, and about more than 1,000. Um, and I took the numbers of yields from that book and I put it in a graph. I made a histogram out of it and I gained a graph. And you can see the graph in my papers, in the paper that I published. And indeed, the average lays around 70.7 or in, rounded off to the next highest level is 71%. So the yield is about 71% on average. I took the 1,024 organic chemical reactions, and just as in the order in the book, it's the book of Vogel, Arthur Israel Vogel, Practical Organic Chemistry. And I took the 5th edition because that was at hand on internet. And you can find it yourself, Vogel's Practical Organic Chemistry. And you can check my claims that on average, the yields of the organic chemical reactions is about 71%. That means that if you perform organic chemical reactions, that you will never get 100%. In some cases, yes, yeah, some Some organic chemical reactions are quantitative, and so 100%. But there's only a few. It's not so much compared to the rest. The rest is not 100%. It ranges from 2% up to 90, 95, etc. percent. So and you can see a graph that which is from your perspective like this, starts high and ups, whoopish, bumps. So it's a very strongly skewed Gaussian curve, where the main numbers is around from 60 to 100%. That's the bulk of it, but with an average of 71%. That means that if you have hundreds of organic chemical reactions, that your yield will be zero, close to zero, 10 to the minus 150. Well, if you take the whole, if you take the, well, life is supposedly originated from Earth, right? That's what most people think. So I took a kind of mass from Earth, a percentage of the the crust of the Earth. I took that mass, and then I allow all these yields to be applied to that mass. And it turned out to be about 10 to the 22nd kilograms of mass. And if you apply those yields a couple of hundred times, I think it's 300 times, in a randomly order, I mean, just as in the Book of Vogel. I mean, the whole Vogel and his team did not organize it by yields, so the yields in the Book of Vogel are pretty random. So I took that order of in that book, and which is pretty random, and I applied that to those kilos, and within 300 times, that means if you have your 300 subsequential organic chemical reactions in the assumption that you can make life from that, then already your yield is smaller than the mass of one proton. Yeah. So if you take the mass of the Earth's crust and assume that the entire mass participated in making life, then only after 300 reactions you end up with a mass that is smaller than the mass of one proton. That means that only after 300 reactions, organic chemical reactions, you have nothing. I mean, one protein is not life. You need a couple of hundreds of molecules, but only after 300 reactions. 300, yeah. And to make a living cell, it requires thousands and thousands of chemical reactions. Yeah. So the Book of Vogel has about 1,024 chemical reactions. And so no matter how, in what order you arrange these yields that are in the Book of Vogel, no matter how you arrange them, it turns out that if you calculate them all down, and then even the entire mass of the universe is not enough to gain life. Even if the whole universe's mass would participate in creating life, and we know it's an absurd assumption, but okay, let's do it. Even if you take the entire mass of the universe, it is not enough within the thousands chemical reactions to do so. I mean, your end mass would be something like 10 to the minus 100 something. So that's zero kilograms. 10 to the minus 100 something kilograms. Even if you have allowed all the mass of the universe participate in the creation of life, even then it would not be enough. So yields, and you need those reactions, you need the organic chemical reactions in order to gain life. I mean that's a requirement. No matter how you do it, it's not possible. Even within a thousand organic chemical reactions, your yields are destroying or are against creating life. So I wrote an article about it, and yeah, it's undeniable. It's chemically impossible especially by random chemical reactions. Now, if you use intelligence, I mean, people are trying to make living cells. I mean, if you use intelligence and fix it here and there and optimize it here and there, okay. Well, using intelligence, yeah, then people may be possible to make some sort of living like cells. They mimic it, but then intelligence is used just as God used his intelligence to create us. And so, only if you use intelligence and be very smart about things, then it may be possible to create some organic living, or well, cells that mimic living cells to some extent. I mean, to make a whole living cell as we know them, it's a different story because they're extremely high complex, more complex than people wanted to admit. But if you put intelligence, human intelligence into it, but basically what you're then proving is that you require intelligence to make a living being. And so it proves actually a deliberate creation. It proves that you need intelligence and intelligence to create life. So it confirms the creationistic point of view. I mean, if you use random chemistry as is supposed to have happened in abiogenesis, then sorry, you're not going to make it. You have to use intelligence in order to even come close, and you need even more intelligence to make it happen altogether, if that is possible. If people so only using intelligence can make it happen. Um, which proves that you need an intelligence in case of making us God, because we are way much more complex than a small living cell. I mean, we are composited of many living cells. So creating animals, plants, and so on, it needs even more intelligence. So it only if people are able to mimic living cells, fine, nice achievement, but it only proves the point of creationism. It proves that you need intelligence, a higher intelligence, to create living beings or life at all. So this is what I want to share. Thanks for watching. I put down here below the Book of Vogel, where you can find it yourself if you don't trust my statements. Also, the link to the paper that I wrote about it. And okay, enjoy it. Thank you so much for watching. If you like the video, give me a thumbs up and like. And see you next time. Hasta la vista. Bye bye.